Hello, welcome to my EP Calculus project. Let's start with this first problem. This is A8. Let's read it. A tank contains 50 liters of oil at t equals 4 hours. Oil is being pumped into the tank at a rate of R of t, where R of t is measured in liters per hour and t is measured in hours. Selected values of R of t are given in the table above. Using a right Riemann sum with 3 subintervals and data from the table, what is the approximation of the number of liters of oil that are in the tank at the time t equals 15 hours? So as you can see from the problem, it's a Riemann sum problem. We're approximating the integral. So first off, since R of t is liters per hour, that means it's a rate. Even though it's not a prime or doesn't look like it's a prime, it is a rate, so we can take the integral of it and find liters. So in a way, we're going to be doing a right Riemann sum as it says, and by doing that, we're going to be approximating the integral from 4 to 15 of R of t dt. That's what we're going to be approximating using this Riemann sum. So if you remember from a Riemann sum, you take the delta x between the x value, or t value in this case, multiply it by the y value, or R of t. So let's find the delta x's first. So from 4 to 7, it's 3. From 7 to 12, it's 5. And from 12 to 15, it's 3. And then since it's a right Riemann sum, we're going to be multiplying them this way. So it'll be 3 times 6.2, 5 times 5.9, and 3 times 5.6. So let's kind of start like that. A for amount, and since we are starting at t equals 4, that's our starting point, and since, if you remember, there are 50 liters of oil at t equals 4, we have to start with a 50. Then then the rest is what's being added in between t equals 4 and t equals 15. Let's start off with 3 times 6.2, then we do 5 times 5.9, and then we finally end off with 3 times 5.6. Then doing all that math together gives us 4.9 liters, which is choice C. I'm going to just kind of give a small demonstration. Let's just say that would be the graph we're doing. This would kind of be the Riemann, how we're doing the Riemann sum, if you remember. It looks something like this. So let's say we're approximating from here to here. This will be a right Riemann sum with 4 subintervals. Actually, this would be a right Riemann sum with 3 subintervals, sorry. It would be like that. Let's just say we're going from here to here. So we go from the right side, because it's a right Riemann sum, we use the right side of the rectangle. And then since the R of t is decreasing, the function is decreasing, and it's a right Riemann sum, we are actually going to be underestimating it. That's not actually really important for this problem, but it's just good to know. Okay, so here we go. This next one is A79. Let f be a function having derivatives of all orders from x is greater than 0, so f of 3 is 2, f prime of 3 is -1, f double prime of 3 is 6, and f triple prime of 3 is 12. Which of the following is a third degree Taylor polynomial for f about x equals 3? Let's start by writing the Taylor series formula. So I'll go up to the third degree because that's what we're doing. F of x equals f of a plus f prime of a, x minus a, plus f double prime of a, x minus a squared over 2 factorial, and finally f triple prime of a, x minus a cubed over 3 factorial. And then if you remember, a is what it's centered at, and this is centered at x equals 3, so we're going to plug in 3 for a in all of these situations. And then so f of a we know is 2, or f of 3 is 2. Then we know f of f prime of 3 is -1, x minus 3, plus f double prime of 3 is 6, x minus 3 squared over 2 factorial, and f triple prime is 12, x minus 3 cubed over 3 factorial. F of x equals 2. I'm just going to clean it up a little. We can make this instead. Then 2 factorial is 2. And 6 divided by 2 is 3, so we can just simplify this to 3. And then 3 factorial is 6, and 12 divided by 6 is 2, x minus 3 cubed. So the final answer is f of x equals 2 minus x minus 3 plus 3 times x minus 3 cubed plus 2 x minus 3 cubed. I said cubed earlier, I meant squared, which is choice E. All right, everyone. Now on to B30. Okay, that works. So let f be a function with the derivative given by f prime of x equals x cubed minus f minus 5 minus x squared plus e to the x, on which of the following intervals is the graph of f concave down. So, if we're doing concavities, first we have to find the double prime, the second derivative. So f double prime of x equals, just do simple power rule, 3x squared, bring down the 3, subtract 1, bring in the 2, 10x, and then it's e to the x, and that's just e to the x again. So that's that simple. Now what we need to do is find, since we have to make a, we have to make a number line, do number line analysis to find concavity. What we should do is find when that function equals 0. That second derivative equals 0. So 3, because that is when the concavity will change, and then we can do some analysis to figure that out. 3x squared minus 10x plus e to the x. Okay, graph it. Alright, that, put a 0 in, graph it. There we go. Second, trace, intersect, guess. The first one on the left is, what is this? It's 0.116. And let's do it again to find the other point where it equals 0. Second curve, guess. And then the intersection is 2.062. Little big, but alright. So now, let's do our number line analysis. So we write f double prime on the top, f on the bottom, number line, and the 2 points are 0.116 and 2.062. So let's look at it. So we have to do positive, negative. Before, let's ignore all that. So before the point 0.116, which is right here, f double prime is positive, then it'll turn negative, then it'll turn positive. So let's just do that. Positive, negative, positive. So that means since f double prime is positive, f is concave up, then concave down when it's negative, and then concave up again. And then, since we're looking for when it's concave down, it's in between these two, making it 0.116 to 2.062, choice C. Okay, now on to C14. What is the approximation of the value of sine of 1 obtained using the 5th degrees Taylor's polynomial, but x of 0 for sine of x? So this is a Maclaurin series. And let me write out the Maclaurin series for sine of x. So if you remember, sine of x equals x minus x cubed over 3 factorial plus x to the 5th over 5 factorial. I'm just going to go up to there because it just asked for 5th degree polynomial. And then the general form is negative 1, n plus 1, x, n plus 1, x to the nth plus 1 power over n plus 1 factorial. Then, so we only need to worry about this. I'm just writing the general form just to know. Then we're just going to plug in sine of 1 equals 1 minus 1 cubed over 3 factorial plus 1 to the 5th over 5 factorial. And then, just to simplify that, sine of 1 equals 1 minus 1 cubed is 1, 3 factorial is 6, 1 to the 5th is also 1, and 5 factorial is 120, making E the correct answer. Okay, so this one, C11, this is actually kind of a tricky one. If f is a linear function and 0 is less than a is less than b, then find the integral from a to b of f double prime of x dx equals all these choices. So I think the best way is to give an example of this problem, is to give an example of a linear function. Linear function is, one where the highest power of the exponent is 1. So let's just say, I don't know, f of x equals 2x plus 1. Then f prime of x equals 2, obviously. And then f double prime of x equals 0. And then we just find the integral of a to b of f double prime of x dx, which equals integral from a to b of 0 dx, and the integral of 0 is just 0. So that makes a the right answer. And just to kind of visualize this a little more, let's draw a graph. So let's say this is 2x plus 1. Then we get the derivative of 2, and then we get the derivative again of, I'm going to do it like this because it's 0. So then we're trying to find the area under this graph, but there is no area because it's just at 0, which is why it's choice A and it's 0. Free response time. Let y equals f of x be the particular solution to the differential equation dy dx equals y times x ln x. With the initial condition f of 1 equals 4, it can be shown that f double prime of 1 also equals 4. So now we have to write the second degree Taylor polynomial for f about x equals 1. And then use that to approximate f of 2. So let's write out the Taylor polynomial formula for about for second degree. F of x equals f of a plus f prime of a, x minus a plus f double prime of a, x minus a squared over 2 factorial. Okay, so they give us f of 1 and f double prime of 1. So now, and they give us dy dx, which means that we can find f prime of 1. Let's just do that over here. So f prime of 1, and we know that it's 4 times 1 times ln 1, and since we know ln 1 is 0, f prime of 1 equals 0. Let's write that a little neater. F prime of 1 equals 0. So this whole thing cancels out. So f of x equals, it'll be f of 1 because it's about x equals 1, and f of 1 is 4 plus f prime of 1 equals 4 also, x minus 1 squared 2 factorial, and that leads to f of x equals 4 plus 2x minus 1 squared. That's the first part of that question, and then let's just do that to approximate f of 2. F of 2 equals 4 plus 2 times 2 minus 1 squared. F of 2 equals 4 plus 2 times 1 squared. 1 squared is 1, 2 times 1 is 1. And then 4 plus 2 equals 6. That's A. Step B, or part B, is we have to use Euler's method starting at x equals 1 with 2 steps of equal size to approximate f of 2. Show the work that leads to your answer. So let's start off by saying, let's start off by writing this. So f of 1.5 minus f of 1 equals dy dx 1 to 4, and then 1.5 minus 1. So what we want to do is go from, since we're starting at 1, and we have to go to 2, and we have to do 2 steps, we're going 1 to 1.5, and then 1.5 to 1. Just 1.5 to 2, sorry. So here, we're going from 1 to 1.5. So f of 1.5, we don't know that. F of 1, we do know is 4 from up here. Equals, we know what dy dx is, so let's plug in some stuff. 1 to 4, 1, 4, 4, 1, ln 1, and this is 1/2. And then since ln 1 here again, that whole thing turns out to be 0. F of 1.5 minus 4 equals 0. F of 1.5 equals 4. So that gives us the point of 1.5, 4. Now we're going to go from 1.5, from this 1.5 comma 4 to 2 comma whatever, and that's what we're trying to solve for. So let's do f of 2 minus f of 1.5 let me write this a little neater. F of 1.5 equals dy dx 1.5 4 to 2 minus 1.5. So f of 2 minus 4 equals, and then this time since it's 1.5 instead of 1, we won't get the 0 with the ln1. 4. I'm going to simplify it, or change it to 3/2 just to make it easier. 1/2. Then just doing some stuff, multiplying these together. 4 times 3/2 times 1/2 is just 3. So it's f of 2 minus 4 equals 3. 3 ln 3/2. And then that makes f of 2 is approximately 3 ln 3/2 plus 4. Okay, last problem. Find the particular solution to y equals f of x. There's a differential equation, dy dx, y x ln x with initial condition f of 1 equals 4. So we're just solving the differential equation finally. So let's just start by writing it again. Dy dx equals y x ln x. So let's kind of move some stuff around. If we divide both sides by y, multiply both sides by dx, we get 1 over y dy equals x ln x dx. Take the integral of both sides, and on the right side we have an integration by parts. So let's kind of go over here and redo it and do it separately on the side. So u dv. So the one we're solving for is x ln x dx. So since we have to follow Lipit, we want to put the ln x here and x dx over here. Then, Then for du, du dx equals 1 over x, because the derivative of ln x is just 1 over x. And then du equals 1 over x dx. And then v, the integral of x dx, is just 1/2 x squared. And I'll put the plus c there for fun. So we have, and then if you remember, the formula for differential by parts is the integral of u dv equals u v minus the integral of v du. So the integral of x ln x dx equals u is ln x, and v is 1/2 x squared plus c. We'll just drop this plus c for now, so do 1/2 x squared ln x minus the integral of ln seconds minus the integral of 1/2 x squared times 1 over x dx. These cancel out, so it's the integral of 1/2 x dx, and using the power rule, divide by 2 because it's x to the 2 now, and it'll be x ln x dx equals 1/2 x squared ln x minus, it'll be 1/4 x squared plus c. Don't forget the plus c, very important. So let's go back to here. The integral of 1 over y is just ln absolute of y equals, bring this thing back up there, 1/2 x squared ln x minus 1/4 x squared plus c. Well then ln, we're gonna have to move that over and flip it so that it's e to the this side on the right. So absolute y equals e to the 1/2 x squared ln x minus 1/4 x squared times e to the c. We can keep the 1/2 x squared ln x minus 1/4 x squared in one thing, as it just complicate things otherwise. So then let k equal plus or minus e to the c. That can allows us to drop the absolute value. Do y equals k e to the 1/2 x squared ln x minus 1/4 x squared. And we know that f of 1 is 4. So let's start plugging this stuff in. 4 equals k e to the 1/2 1 squared ln 1. That becomes 0 minus 1/4 1 squared. And then, since this becomes 0, it becomes 4 equals k e to the negative 1/4. Move e to the other side. Divide by e to the negative 1/4. It's k equals 4 e to the 1/4. Plug that back in. Y equals 4 e to the 1/4 times e to the 1/2 x squared ln x minus 1/4 x squared. We can combine the fractions because combine the exponents because we're multiplying, same base. So y equals 4e to the 1/2 x squared ln x minus 1/4 x squared plus 1/4, making that our correct answer.